Okay, here we go, guys. We have 5.6 quadratic equations, and we're actually going to be solving quadratic equations here. So what does it mean to solve a quadratic function or a quadratic equation, actually? We're going to find a value for x or values for x that make the equation true. So here in just a second, we're going to go and figure out what those values are. A couple different words for solutions that you can use for a quadratic function. You can say x-intercepts, roots, or zeros. Those are all the same things. Solutions, x-intercepts, roots, and zeros. There's four of those there. So those are all interchangeable. And one of our methods that we're going to be using quite a bit today is factoring. So before we factor, we're going to set our equations equal to zero, and that's real big, so I put a star next to that. That is how we're going to be able to solve with factoring and then actually graphing as well. Okay, here's why. We have this thing called the zero product property. So if you have something times something else equals zero, either the first something or the first variable is equal to zero, or the second thing equals zero. So this will generate two different solutions. Sorry, all my stuff is going off there, but yeah, this will usually generate two different solutions when we do these here. So let's talk about how to solve something like this. So once again, we need it equal to zero, so we're going to add 12 to both sides, cancel it out on the right side. So that'll be that right there. Okay, and then with solve by factoring, we're going to factor this left-hand side, and it's still going to be equal to zero. And if you need a little bit of a recap on factoring, watch the previous video for that. So we need something that multiplies to 12 and adds to negative 7. So I think in this case here, that would be x minus 4 and x minus 3. Doesn't matter on the order that you write that. And then we're going to use the zero product property to solve from here. And we split this up into two cases. Either that first thing, like if this is a times b is equal to 0, either the a thing is equal to 0, or the x minus 4 is equal to 0, or the x minus 3 is equal to 0. Okay, and then we will finish solving by adding 4 to both sides or adding 3 to both sides. And you have two different solutions right here. Either x is 4 or x is equal to 3. And if you go plug both of those back in to the original equation one at a time, you should get that that thing on the left side equals that thing on the right side. And that is how you solve by factoring. Okay, now sometimes you might have a coefficient out in front, and in this case we can't divide everything by 15, so we just kind of leave it like that. We're going to do the divide and slide method here, so we'll go 4 times negative 15. That should be negative 60, and then I guess two things that multiply to negative 60 that add up to negative 17 right there. And I think we can roll with negative 20 and then positive 3. So that'll be x minus 20, and then x plus 3, and then equals 0. Now remember, we still got to do divide and slide here because x times x is not 4x squared. And we go back and divide by the a coefficient. That's going to be 4. Okay. X minus 20, we can rewrite that as x minus 5. And then you're going to slide that 4x, or the 4 out in front of x. That'll be 4x plus 3 equals 0. And then you split it up and solve your individual equations. Either x minus 5 equals 0, or the 4x plus 3 equals 0. Over here on the first equation, add 5. That can be done in one step. Now the second one here, we'll have to do 2 steps. We'll have to subtract 3 and then divide by 4. I guess negative 4 over 3, and then we're good to go. Right there. Now some people make this connection here. This fraction that we got here, negative 3 over 4, notice that that is almost the same thing here when we had it in our factored form right there. It's just the opposite sign right there. And then also, I guess if you go look here at the minus 5, notice opposite sign here, you got positive 5 there. So some people kind of use that as a shortcut to quickly go and get your solutions. Okay, now the next one here, got a lot going on here. One suggestion I make is try and keep your x squared, or in this case our y squared, try to keep that positive. So we want to move all of this junk here to the other side. So we'll add 14y to both sides. Make sure you add it to the corresponding spot right there. So plus 14y. And then I guess this here is add 48 to both sides. And those will cancel out there. And then I guess we have 3y squared plus, what is that, 36y. And then plus 108. And equals 0. Okay, and then from here, if you go and look, everything is divisible by 3. So yesterday in the factoring lesson, we said, oh, just put 3 on the outside of the parentheses, but I'm going to write it a little bit different here today. I'm going to say divide this left side by 3, and also go and divide that right side by 3, because it's an equation. You got to keep it balanced. So that gets us y squared, and then I guess, what is this, 12y, and then what is this, like 30, with the remainder 136 right there. And then the right-hand side, when you divide that by 3, it just comes out as 0 right there. So we can actually just cancel the 3 out. And then we're going to go factor from here. So we need, what was that going to be? Y plus 6 and then y plus 6. You could also write that as y plus 6 squared, but we'll leave that as y plus 6 right there. And we'll split it up into our two cases. Y plus 6 equals 0. And then y plus 6 also equals 0. So that's y equals negative 6 and y equals negative 6, which really, that just means there's only one solution here. And if we go and graph it, I guess that means we'd have, some type of value right here at negative 6, and it just touches once on our graph. So that's how you do those problems right there. So not too bad. You've done this in Algebra 1, so this shouldn't be anything too crazy new, which is nice. And you can also solve by graphing. So this is asking here, what are the solutions of the quadratic equation solved by graphing here? All right, now actually one little thing here. I think these are actually technically supposed to say equals 0 real quick. So I'm going to kind of scratch out that right there. But really, this thing here, if we're going to solve by graphing, we're going to actually type that x squared minus 3x plus 2. We're going to type that into our graphing calculator. And then we're going to go and look specifically on the graph at the x-intercepts. Wherever it crosses the x-intercepts is when the y value equals 0 right there. So I'm going to switch here to my graphing calculator thing. I'll kind of be switching back and forth. So we go and graph by y equals. Hopefully you've seen this a few times. Y equals, and then I guess we had x squared. And then minus 3x. Make sure you hit minus and not the negative. Minus 3x. Sometimes it's slow. And then plus 2. Okay, and then we're going to hit graph. And hopefully it shows up here. Now it looks like our x-intercepts here are at 1 and 2. So to verify that, we can look at the table here real quickly. Second graph. And yeah, notice there you got 0, 2, 1, 0, 2, 0, and then 3, 2, 4, 6. Okay, so that's a couple points right there that we can go and copy over. So I'm going to copy those over. Let's see here. I gotta do this here from memory. And it was right here, and then I think it was 3, 6. So a hair off the graph. Negative 1, 6. Now with this one here, if you kind of look here, you can see symmetry happening, and it's between two x values, which is kind of annoying because that means like the vertex might be somewhere about right there. So it's kind of hard to get the vertex on these, but really we're not concerned so much about the vertex. We're concerned about these x-intercepts. So we can go and say the two x-intercepts are the two solutions now to this equation, x equals 1 and x equals 2. And guys, we can get the same exact answer if we take this same exact equation right here and factor it. It's a different way to do the same type of problem. So I'm going to show you here with factoring. We can write that as x minus 2 and x minus 1. And then we can split it up into our two cases, x minus 2 equals 0, or x minus 1 equals 0, and then add. And notice we get the same exact thing. So sometimes factoring, in my opinion, might be a hair quicker, especially if everything comes out real nice and clean. But graphing is also another valid way that we're going to be using today. So that is that. not too bad. Let's look here at this next one here. Notice got the negative out in front. Really, we're trying to figure out when the y values are equal to 0. So really, I mean, technically this is the best way here to write the equation. So we'll go and graph that here using the graphing calculator again. So we'll go here, y, I'm going to clear that out. Make sure we put the negative out in front of x, negative x squared, and minus 7x, and minus 6. And we'll take a gander at the graph. So there's that right there. Nothing too fancy. Looks like a vertex might be between 2 points again, which is always a little bit annoying, but we'll manage. And but it looks like our x-intercepts cross at real nice points here. It looks like at -1, what is that? -1, 2, 3, 4, 5, 6, and -6. Once again, go look at the table to verify. And then we'll go look at some examples where they don't come out clean here in just a moment. Yep, there's a -1. Okay, good. So actually bear with me. I'm going to copy a few points over here. Or you can skip ahead until I'm done with this. Yeah, so -6, 0, -5, 4. What do we have here? -4, 6. So I guess this will kind of come off our graph here. Let me show you what I'm working on here. Oh, I guess here we go. We're going to just scoot this over. And that way we can see the graph. Okay. So anyways, yeah, there's that. Once again, vertex is going to be in between these points here. So something kind of like this. Once again, we are focused on these x-intercepts. Those happen at x equals -1 and x equals -6. So not too bad there. So I like this next one here, going and finding the x-intercepts and solving this here with a calculator. Notice, first of all, it's not even equal to 0, so we need to subtract 4 from both sides. These always need to be equal to 0 before you can get it ready to graph. So I think that gets us -2 right there. Okay, and we might be able to factor this, but we're going to use our graphing calculator for this, and then I'll write out the steps here for you. So let's go here and graph that. Now, if y'all recall, it had an n squared. We're going to use x. So we'll go 6, then x squared, plus 11x, and then I guess -2. If we hit graph, we're probably not going to have nice x-intercepts. It looks like one of them came out real good. But notice this one here is kind of between 0 and 1. I guess you could try and use a decimal for it, but usually we're going to want you guys to be real precise on this. So to get our graphing calculator to tell us the actual decimal that it is crossing there, we're going to hit second and then trace right here. And then remember, another name for an x-intercept is a 0. Okay. Now, you got to now go and move the little blinky guy right here. We're going to move him left and right. And you got to line it up on one of your x-intercepts. I guess I'll do this one that's here to the right. And when it says left bound, it means you need to go to the left of that one x-intercept. So I'm focusing on this right one for just a second. Go to the left of that x-intercept. Now go to the right. When it says right bound, go to the right of that x-intercept. Basically, what you're telling your calculator to do is, in between these two little arrows, look for the one x-intercept there. So if you hit enter, it should give us that decimal there. Apparently, n is negative, or not even negative, I'm sorry. That's just 0.1667, which I think is actually kind of like a, I believe that's 1/6 there, if I remember correctly. But we'll just use a decimal here for now. Okay, and then from there you can go and hit second, trace, and then we're going to go to 0, and then we're going to scroll over here to this other 0 here. Now it looks like it's at -2, but just to verify, we're going to go ahead and do all this here. So go to the left of your 0, it says right bound, go to the right of your 0, hit enter again, and then one more enter, and then yep, that was at -2. So we'll take both of those values. N is equal to 1.667, and then n is equal to -2. And then we will write those down right there. Those are our solutions right there. So sometimes they don't come out super clean. As far as the steps, I guess I typed into y equals. Oh, well, here, let's put this actually. Let's solve for y, or let's say set equal to 0. So set equal to 0, type into y equals, okay, use second trace 0 to get your zeros, and then I guess I'm not sure what was supposed to go there for the next step after that here. I guess you could say graph between them, but yeah, that's it right there. Really, those are the big things. Set equal to 0, type it into y equals. If you want to, I guess, fill in this last blank here, you can just say graph and then second trace 0. But anyways, that is it there. So, all right, next few examples. I think you got a few word problems here that we're going to go ahead and do here, dealing with your quadratic models here, and then we're going to, I guess, tie in some of the x-intercepts and the solutions here to these here. So look at this. You got the function right here, models the path of a kicked soccer ball. The height is y, the distance is x, and the units are in meters. How far does a soccer ball travel? How high does the soccer ball go? Describe a reasonable domain and range for the function. Okay, so let's something like this. You probably have a graphing calculator for. So we're gonna switch back to the graphing calculator. We got the negative 0.03. Oh, and actually I need to clear out whatever is here. So let's try that again. Negative 0.03. And then I guess x squared. Hopefully I typed that in right. Okay, and then plus 1.6 x, 1.60x, it doesn't matter if you have that. I'm going to graph. I might not be able to see the whole thing. Yeah, just as I was thinking here. So I can't really see it. You can kind of see it curving here. It kind of looks straight, but it's actually curving. We're like really zoomed in. So we're probably too far zoomed in here. A couple of things you can do. You can hit the zoom and then zoom out, and let's see if that fixes our problem here. Okay, so we can kind of see the top here, but we can't see far enough right. So another thing, instead of hitting zoom out again, we can just go to the window, and then we can go and change the different, how high, how low we can see. So x max and min, that's how far to the left and how far to the right you can see. And then y min and max is how far low and how far high. So I think we could see high enough. If you kind of look here on the graph, you can still see that. But we need to see a little bit farther to the right. So I'm going to change that the x max. Let's change that to, I don't know, maybe like 70 or something like that. And then let's see if we can see enough. So looks like, yep, we're going to be able to see plenty enough right there. So I guess you had a few questions here that it was asking here, so I'll read those to you. It was asking how far, first of all, does the soccer ball go? So if this is the path of the ball, then we need to figure out how far it goes by looking at the x-intercept. And once again, we will use second, trace, and then 0 for that. So go and get your blinky guy right there. Get it kind of close to the 0. Get it to the left of your 0. This is right boundary. Get it to the right of your 0. Hit enter again. And apparently at 53.3, and I think the original problem said we were in meters. I'm going to put 53.3 meters. That's how far. Okay, and I'm writing that down here. I'll switch it back to the other screen in a second. It's also asking how high does a soccer ball go. So this is actually tying into the max and min stuff that we have been going over here for the past few days. So second, trace, and then we're going to use the maximum. Okay, very similar to a 0 here. You're going to get it close to the maximum value. When this is left boundary, you're going to go to the left of it. You're going to hit enter. Now you're going to go to the right. You're going to hit enter, and then enter one more time. Now it'll give us the order pair. So the vertex order pair is at 26.67, comma, and then I guess 21.3 repeating right there. So if it's asking how high, Remember, the height was the y-axis, so that was going to be, I guess, 21.3 meters high, I guess. And then let me see. And then describe a reasonable domain and range for this graph here. So if you think about the situation here, it's starting here at 0, 0, and it goes, and then the graph kind of comes back down, but we can't really have a negative height. So we basically just have this piece of the curve here, and we don't have anything to the left over here in this negative section of the graph here. So that should help us write our domain and range. So our domain is going to start from 0, and then it's going to go all the way to where the ball landed, and that x-intercept was 53.3 from the previous, I guess, the x-intercept. And then as far as the range, that's usually how high and how low, so it doesn't go down forever. The lowest it starts is at 0, and then the highest it goes is to that 21.3. So as far as writing your domain and range, a reasonable domain for this problem right here, I would say starting here at 0, so I'll put a bracket, and then it goes up to, I guess, the 20, where was it? Oh yeah, 53.3. I think that was repeating there, so 53.3 repeating right there, and then bracket right there. Now as far as range, the range it went, started at 0, and then it went up to 21.3, repeating. That would be a reasonable domain and range. So make sure you get that written down. Pause the video here for a second if you need that. So go ahead and move along. Okay, solve this equation by factoring. Okay, so I guess it's one where you got some numbers out here in front. What do we have? 3 times -2. That should be multiplies to -6 and then adds up to -1. We could go -3 and 2. So we'll go x minus 3, x plus 2, and then divide and slide. Divide by 3, divide by 3. First one is x minus 1. Second one here is 3x plus 2. Okay, from here, set them equal to 0. X minus 1 equals 0. This is the split and solve part. You got 3x plus 2 equals 0. Add 1, subtract 1, or subtract 2, and then divide by 3. -2/3. So -2/3 is one of the solutions. The other solutions is x equals 1. So hopefully we got factoring down by now. Okay, look at this next one here. Write a quadratic function that has zeros of 2 and 7. And actually, I kind of like this one. We're going to tie it into the previous answer. So the zeros are 2 and 7. So that means the final thing needs to have x equals 2 and then x equals 7. And I don't know if you guys have noticed here, and I kind of pointed it out once here. Notice whenever you have your solutions, notice when you write them as factors, you write it as x and then minus whatever that number is. So if I was going to write the solution of x equals 2, we write it as a factor as x minus 2 with the opposite sign right there. Now as far as this x equals 7 goes, we're going to write that as x minus 7 right there. So that's kind of like thinking backwards right there. And that right there would be a quadratic function with those 0 values. Now some people, you can get real fancy here as far as like how tall or how, like where the vertex is. So sometimes there's an a value out in front. But since they just told us they wanted those zeros, I'm not going to worry about the a value as far as how high or how low. We're just concerned where does it cross the x-axis. And that would get you to cross the x-axis there. Okay, and then I guess we got this last one here. So last word problem here. Here's your function. Models the height, line and feet of a football that is kicked from the ground at time x in seconds after it is kicked. Does the football reach a height of 50 feet? If so, when? And then after how many seconds does the football land on the ground? So it's a little bit different here. Instead of it being like this previous problem where the parabola is focusing on the path of the ball, this is more of like the height versus the time in the air. So it's a little bit different. It's still going to be a parabola. So I guess they're asking, when does the football reach a height of 50? And there's a couple of ways we can do this here. We can go and actually look at the graph, see if it ever hits a height of 50. And then if not, then we wouldn't be able to get a solution, I guess, for it. And then what else we got here? And then how many seconds does it take to land on the ground? So actually, I'm going to do the how many seconds does it land on the ground, because we could actually solve this one here by factoring. So look at this here. You got 64x right there. So notice with this one here, both of those numbers are divisible actually by 16. So, and actually they're both divisible by negative 16. So I'm going to actually divide both sides by negative 16 right there. And that would be, I guess, 0 equals x squared and then minus 4, kind of like that. And actually minus 4x, I guess I should say there. And then notice here, you can undistribute. You can actually factor out 1x right there and just make this as x minus 4. And that's just factoring out the common factor there. And then after this here, we can split it up here. We can say, okay, that means x is equal to 0, and then x is equal to 4 right there. Those would be your two different solutions. Now, if you think about it, x equals 0, that's a logical x-intercept, because that means it's just starting here at the ground. Then it's going to go up, and then it's going to come back down, apparently after 4. And remember, x is in seconds right there, so that means 4 seconds. So that's how you figure out how long it's in the air. Now, guys, you can do all this with a graphing calculator as well. But this one had simple enough numbers so where we could actually do that with solving with factoring real easy there. Now, as far as how do you figure out if it hits 50? Well, just take that 50 feet and we're going to plug it in for y. This one might be a little bit harder to graph here. So if we go 50 equals negative 16x squared plus 64x, I guess we could move that 50 to the other side and then possibly solve by factoring. Now, actually, another way you could do this, actually, now that I was thinking about it, is let's type this into our graphing calculator. We're going to type in the original equation here. So not with the 50. We'll come back to this 50 here in a second. So actually, type in negative 16x squared. And then what was it? Plus 64x, I guess. Okay. And we can hit graph. I'm not sure if we'll be able to see the whole thing. Okay, so it goes like way high. And then it comes down real quick here. So you can play around with the window here. I think I'm going to make the window, it only goes out to 4 seconds on the x-axis. I'm going to make the x max 4. I guess I'll change the x min. You can, I don't know, I'm going to change it, I guess, to -1 so I can kind of see. And then apparently it goes really high up. So apparently we're going to see if it goes up to 50 feet. And our y max right now is at 40, so I'm going to change that to like 100 or something like that, just so I can see the full graph. And, yep, looks like we can see the whole graph. Okay. Now to see if it hits 50, we could just go and look at the table. And it looks like at some point here, between 1 and 2, it hits 50 somewhere. So a good way to go and see where it hits 50 is actually, we're going to type in for a second equation for this red one here. We're just going to type in y equals 50. When I hit graph again, there are 2 points where it hits that 50 feet mark right there. It actually even goes above. And then it comes back down. So there are 2 points where it hits 50 right here at these 2 different time intervals right there. Or those 2 different time points, I guess. So to figure out exactly where that is, we can hit second, trace, and we want to actually figure out where those intersect at. So we'll hit that. Now, since it intersects twice, go put it near the intersection that you want to look at here. So I'm going to go put it over here to this left intersection. Hit enter, second intersection, yep, hit enter. Apparently that comes at about 1.06 seconds, or 1.06 seconds. It hits that 50 feet. So that'll be one of them right there. Now if I want to go find the other one, I'll hit second, trace, intersect. But this time I'll go and put it over at the right intersection. So enter, enter, enter. And then that'll be 2.94 seconds, I guess. Okay, and then those are 2 time values that happens at. So we can go fill the rest of that in here. at 1.06 seconds and then 2.94 seconds. Now you could theoretically go and use this equation and then look specifically, set it equal to 0 and then see where the equation equals 0, or in other words, where the x-intercepts are. But I would just do that trick with two graphs if you already have a graphing calculator to work with there. So I believe that is it here for this unit.